So, good morning, dear children. In the last class, we have seen how Newton gave an explanation for the propagation of speed of propagation of a sound in air. And hope you remember he told the process was an isothermal process, and as a result of this isothermal process, the bulk modulus of uh, air can be replaced with pressure exerted in the medium. And upon substituting the values like in the equation V is equal to root P by rho, he got an equation like this and he got an answer 280 meter per second. And we told it was not as the observed value, which was 331 meter per second. So we told this Newton's formula was not acceptable. So remember the postulate suppose suggested by Newton was sound propagation is an isothermal process. That means when sound passes through a medium, there is no change in the temperature of the medium. That's the meaning of that. When sound propagates through a medium, there is no change in the temperature of the medium. As per that assumption, he got the answer 280 meter per second, but it was not correct. Later, another scientist came. His name was Laplace. He tried to correct Newton's formula, saying that the sound propagation through air is not an isothermal process. It's not an isothermal process. That means when sound passes through the medium, temperature is not constant. There is a change in the temperature. But that particular medium through which sound propagates, the medium is not absorbing any heat from outside. And there is no heat flow from the medium to the surroundings, and he called that kind of process as adiabatic process. So as per Newton, there is no temperature change in the medium, but as per Laplace, there will be temperature change in the medium through, suppose if sound travels through air, there is a change in the temperature of the molecules present there, but there is no heat exchange between surrounding and the medium. That's what he said, and he told that process is called an adiabatic process. And already we have in thermodynamics, we have a particular equation for this adiabatic process. That equation is PV to the power gamma is a constant. This is a gamma is a constant. PV, you know, the medium's pressure, volume, and gamma is a ratio which is gamma is Cp divided by Cv. I'll explain what is Cp and Cv. We have studied about molar specific heat capacity. That means 1 mole of a substance you take, maybe a gas, it's 1 mole you take. The amount of heat required to increase its temperature by 1 degree Celsius, that is called a molar specific heat capacity. We have equation for that also, 1 by n delta Q by delta T. We have seen in the previous classes. Now that was represented as C. C was the molar specific heat capacity. Now this molar specific heat capacity depends on two factors. One is the pressure of the medium, another one is the volume of the medium. Both it depends. So the specific heat capacity, molar specific heat capacity, when the medium's pressure is constant, is known as Cp. That is molar specific heat capacity at constant pressure. So if you maintain the pressure of the medium, then its specific heat capacity, molar specific heat capacity, is called Cp. Similarly, you can increase the temperature of the medium by 1 degree Celsius by keeping the volume constant, that is Cv. Their ratio Cp by Cv is known as gamma. And for an adiabatic process, Pv to the power gamma is constant. This is an equation for the adiabatic process. Pv to the power gamma is a constant. Now we have done, hope you remember the previous equation, that is Pv is a constant. We told Newton said Pv is a constant. Newton's formula, as per that, Pv was a constant, and we told if you differentiate, when he differentiated, he got P is equal to B. That is how he replaced the equation. as v is equal to velocity is equal to root p by rho. He had replaced like that. Now Laplace is coming with another equation, that is v raised to gamma is a constant, where gamma is cp by cv, that is a constant, a number for a given medium. It has no unit or anything, it's just a number for a given medium. Now, if so, we have to differentiate this PV to the power gamma, a, a constant. That also we have to differentiate. As it is in the previous case, a right side constant, if you differentiate, it will be 0. PV to the power gamma, we can use our product rule. I'll show you how to do that. Here we have a d of PV was P dV plus V dP. Hope you remember this. But now instead of PV we have a d of PV to the power gamma. This is equal to a constant. It's differential. D of a constant. D of a constant is 0. So d of PV to the power gamma is equal to 0. So now this is our first term, this is our second term. So answer to this is first term P, differential of V to the power gamma, plus second term v to the power gamma differential of p. This is equal to 0. Now look at the term v to the power d of v to the power gamma. That term alone, this term alone, we can analyze. We had an equation d of x to the power n is equal to n x to the power n minus 1. We had an equation like this. So here, as per that, d of v to the power gamma is equal to gamma, n is the number gamma, v to the power n minus 1, gamma minus 1. Along with that, there will be a dv. This is a rule for that. So here, if you use the first term, this equation, if you take, we get a p into, instead of dv raised to gamma, we have gamma v to the power gamma minus 1 dv plus v to the power gamma dp is equal to 0. This is the equation p gamma v to the power gamma minus 1 dv plus v to the power gamma dp is equal to 0. Now that equation is what you are seeing here, p into gamma v to the power gamma minus 1 dv plus v to the power gamma dp is equal to 0. We can take this term to the left side, then it will become minus v to the power gamma dp. Then we can keep gamma dp here, gamma and dp here. If you take gamma and p here, this term alone you can keep here. These two we take to the right side. So minus v to the power gamma dp divided by v to the power gamma minus 1 dv. So this one, if you go for a solution, v to the power gamma by v to the power gamma minus 1, this will get it as v to the power minus 1. This gamma v to the power gamma and v to the power gamma will cancel, then we will get it as a v. This v to the power gamma minus 1 I can write as, how it comes is, v to the power gamma minus 1 I can write as v to the power gamma divided by v to the power 1. V to the power gamma divided by v to the power 1. This is what this. So this gamma and gamma term cancel. V dv by v is here, dv by v is coming here. This dv by v, this is dv and by v, that dv by v I have taken here, dp is already there. This was our bulk modulus. Hope you remember, this was our bulk modulus. So previous equation we told p is equal to b, then we replaced it as p by rho. But here now b is equal to gamma p. So this equation becomes b by rho, that becomes gamma p by rho, gamma p divided by rho. Now let's substitute the values of air for all these parameters. For air, gamma is 7 by 5. It's a number I told already, Cp by Cv, it's 7 by 5. And atmospheric pressure, our P by rho and all, if you substitute this value, we have already, as per Newton, it was 280. This number was 280. Along with that, we have an additional term root gamma, that is root of 7 by 5, which we are getting 331.1.3 meter per second. that is the correct value of speed of sound in air. And as per that, we agree Laplace equation, we say Laplace corrected Newton's formula.